Humans have always strived to conquer the realm beyond our planet. But even in near space, physics behaves in strange ways, challenging our understanding of the world. In this film, we'll uncover 9 curious facts about near space that will change your perception of the universe. Humankind continuously strives to conquer the space beyond Earth. Yet even in the closest reaches of space, there are laws that science does not fully explain. First, flame in space. On Earth, a flame has an elongated shape due to the force of gravity. The gas molecules that make up the air are pulled toward the planet in the same way as all other objects with mass. The fire heats the air and causes the molecules to move faster. The accelerated gases disperse in all directions away from the flame and collide with slower, that is, cooler, molecules. In the vacated place come slow molecules, including oxygen, thanks to which the fire continues to burn. Such mixing of gases is called convection. This process cannot be carried out in a state of weightlessness, because the density of gases there is the same. That's why fire burns very badly on space stations, thankfully. The flame there is not elongated but appears as a sphere. Moreover, the fire quickly goes out because the oxygen molecules cannot reach it in time. Two, the endless crystal. However, there is one process that benefits from the lack of convection: crystal growth. On Earth, crystal growth is limited by convection currents, which prevent uniform growth. In microgravity, where there is no convection, crystals can grow to impressive sizes and shapes. Three, gases and drinks in space. Carbonated drinks have their characteristic taste thanks to the carbon dioxide that comes out of the liquid in the form of bubbles. In a state of weightlessness, carbon dioxide does not escape from the drinks and remains dissolved in them, even after reaching the astronaut's stomach. It is impossible to release it by burping or in any other way. That's why consuming beer, let alone champagne, in space only leads to trouble. Fourth, boiling in space. On Earth, boiling water forms many small bubbles that rise to the surface. It turns out that in weightlessness, boiling liquid turns into a single giant bubble, which grows by absorbing smaller, randomly formed bubbles. Five, gravity in near space. Many people think that there is no gravity in space, but that's not true. Gravity still affects objects even in microgravity conditions. It's what keeps the International Space Station in orbit. Sixth, reproduction in space. If life in weightlessness is difficult, then giving birth in orbit, whether for humans or other mammals, seems impossible. Experiments have shown that developing embryos in microgravity do not grow properly, leading to their death. Gravity is necessary for the correct formation of organs. The development of the fetus is a very complex process regulated by numerous external and internal factors, one of which is Earth's gravity. Seven, loss of bone mass and muscles. Living creatures are composed of the same molecules and atoms as inanimate matter, so the anomalous, from a human perspective, changes in the laws of physics also affect them. For example, during the first long-term space missions, it was found that calcium quickly disappears from the bones. In a month in orbit, astronauts lose at least 1.5% of their bone mass. Scientists suggest that the mechanisms responsible for maintaining the normal condition of bones depend on external stimuli, including the constant pull of Earth's gravity. Eight, bacteria in space. Some creatures in the state of weightlessness turn into monsters. In 2006, the crew of the space shuttle Atlantis took into orbit the bacterium Salmonella typhimurium, the main culprit of intoxication in humans and animals. After studying the salmonella brought back by the astronauts, researchers found that, compared to terrestrial bacteria, the space ones in weightlessness had a significantly increased virulence of Salmonella typhimurium. Therefore, during long-term missions, such as to Mars, people should be concerned not only about radiation or extraterrestrials, but also about native bacteria. Nine, a rose in space. In 1998, astronaut John Glenn aboard the shuttle Discovery planted a rose of the overnight sensation variety in orbit to find out how it would smell beyond Earth's confines. It turns out that in a state of weightlessness, the rose has a completely different aroma. Near space is full of unusual phenomena and challenges. Understanding these facts helps scientists and astronauts better prepare for exploring our universe. The future of space exploration depends on understanding its mysteries. If you enjoyed this film and want to learn more about the extraordinary world around us, please like, share, and subscribe to our channel. Your support helps us continue to explore the unknown and bring more amazing stories to light.